we're asked to put x squared minus 6x plus 14 into the form x minus p all squared plus q. We're asked to complete the square. So we've got x squared minus 6x, and I'll put this plus 14 at the end. We take half the coefficient of the x term, so that's half of negative 6 is negative 3. We then square that. Negative 3 squared is 9. I'm then going to place plus 9 minus 9 after the negative 6x. The first three terms then give you the square, which is always x together with half the coefficient, the negative 3, x minus 3 all squared. We've got at the end this minus 9 plus 14, which is plus 5. And that's us now got it into the form x minus p all squared plus q, so that the value of q is plus 5. And our answer to this question is B. We're asked to find the gradient of this line. And the gradient of this line is given by the tan of 150 degrees. And this will be an exact value. 150 degrees is related to an acute angle of 30. Second quadrant is 180 minus 30, which is 150. The third quadrant would be 180 plus 30, would be 210. And the fourth quadrant would be 360 minus 30, which is 330. The tan of two of these, tan of 30 and the tan of 210, will both give the answer 1 over root 3. So tan 30 and tan 210 is positive 1 over root 3. The other two values, tan 150 and tan 330, will give the negative of 1 over root 3. So what we're after here is negative 1 over root 3. So our answer is B. This question, we're given a right angle triangle and we're asked to find the cos of 2a. In the triangle we see that the cos of a is the adjacent over the hypotenuse, which is 4 over 5. And then on our formula sheet we've got a formula for the cos of 2a. There's three formulas, but the one we could use here would be 2 cos squared a minus 1. Now cos squared a means whatever cos a is, you square it. So this is 2 times cos a squared minus 1. Fitting in the fact that cos a is 4 over 5, that's 2 times 4 over 5 squared minus 1. Now 4 over 5 squared is 16, 4 squared over 5 squared, which is 25. So this is 2 times 16 over 25, take away 1. 2 times 16 over 25, we just times the top number, so that's 32 over 25. And 1 can be written as 25 over 25. Taking them away, 32 over 25 minus 25 over 25 is 7 over 25. And that's the exact value of cos 2a. So our answer is part A. So we have to find the maximum value of 2 minus 3 sine, and in brackets x minus pi by 3. First thing I'm going to do is to change the order of this round and write it as minus 3 sine x minus pi by 3 in brackets plus 2. Now looking at this part here, the sine bit, the maximum value that sine can be is plus 1 and the minimum value is minus 1. If we then multiply that by negative 3, that means that the minimum value that this part can be is negative 3 and the maximum is plus 3. What we're then going to do, once we've got this part, we're going to add on 2 to the minimum value, giving us a minimum value of -1. And adding on 2 to the maximum value of this part gives us 5. So we know that the maximum value of this expression is actually 5. So the answer is either going to be B or D. What we now need to work out is which value of x is going to give us this maximum value. Is it x is equal to 11 pi by 6 or 5 pi by 6? So what we'll do is I'll fit in each of these values and see which one gives the maximum. So fitting in a value of x is equal to 11 pi by 6. -3 times the sine of, and in brackets instead of the x, 11 pi by 6 minus pi by 3 plus 2. Pi by 3 can be rewritten as 2 pi by 6, 2/6 pi. So in the brackets is 11 pi by 6 minus 2 pi by 6. So that's -3, the sine of the brackets, plus 2. Now 11 pi by 6 minus 2 pi by 6 is 9 pi by 6. So what we've got is -3 times the sine of 9 pi by 6 plus 2. 9 pi by 6 can be simplified if we divide the top and the bottom of the fraction by 3. That gives us 3 pi by 2. Now, I know that the sine of 0 is 0. The sine of 90, or the sine of pi by 2, is 1. The sine of 180, or sine pi, is 0. And the sine of 3 pi by 2, which is the same as 270 degrees, is -1. So the answer to this is -3 times the sine of 3 pi by 2, so that's -3 times -1 plus 2. -3 times -1 is plus 3 plus the 2, and in fact that does give us our maximum value of 5. So there's no need to try this other value of 5 pi by 6. Our answer must be B. So we've got two graphs here, y equals 4 to the x and y equals 3 to the 2 minus x. We're told that the graphs intersect at the point T. To find out where two graphs intersect, it's simultaneous equations. So these curves will meet where y equals y, where 4 to the x is equal to 3 to the 2 minus x. If we now take log to the base a of each side of this equation, a is any number bigger than 1. Then log to the base a of 4 to the x is equal to log to the base a of 3 to the 2 minus x. Now the third law of logs tells us that if there is a power inside a log, the x in this case and the 2 minus x in this case, the third law tells us that we can take this power and pre-multiply the log by it. So log to the base a of 4 to the x can be changed to become x times log to the base a of 4. Equals, on the right hand side, the 2 minus x is the power. We can take that and multiply it by log to the base a of 3. Multiplying out the right hand side, 2 minus x in brackets times log to the base a of 3. That gives us 2 log to the base a of 3 minus x times log to the base a of 3. Taking the minus x log to the base a of 3 over to the left hand side, gives x log to the base a of 4 plus x log to the base a of 3. On the right hand side we're left with 2 log to the base a of 3, but using the third law again we can bring this 2 up and make it a power. So this is log to the base a of 3 squared, which is log to the base a of 9 on the right hand side. There's a common factor on the left hand side of x, so that's x, and inside the brackets log to the base a of 4 plus log to the base a of 3. But log to the base a of 4 plus log to the base a of 3 using the first law of logs is log to the base a of 4 times 3. So on the left hand side we've got x times log to the base a of 4 times 3 is equal to log to the base a of 9. Log to the base a of 4 times 3, that's log to the base a of 12. That's multiplying the x. So to get x, we take the log to the base a of 12 over to the right hand side and divide. So the x is equal to log to the base a of 9 divided by log to the base a of 12. And this is the answer for part A. The x coordinate of t we have now written in the form log to the base a of p over log to the base a of q, where p is 9 and q is 12. For part B, we're asked to calculate the y coordinate of t. First of all, we'll need to get a numerical answer for the x coordinate of t. The result that was worked out in part A, that x is log to the base a of 9 divided by log to the base a of 12, will hold for any value of a greater than 1. On our calculator, we've got a log button, which stands for log to the base 10. So we'll choose a equal to 10, and then to work out a numerical value for x, we just need to work out on the calculator log to the base 10 of 9 divided by log to the base 10 of 12. Log 9 divided by log 12 on the calculator is 0.884 to 3 decimal places. That's the x coordinate of the point t. To find the y coordinate, we need to fit this value of x into either of these two equations. It would be easier to fit it into the y equals 4 to the x equation. So y is equal to 4 to the power 0.884, which is 3.41. So the coordinates of t are 0.884, 3.41. And the answer to B, the y coordinate of t, is 3.41.